Hello everyone! In today's video, we will talk about autonomous operating profiles and what autonomy means in drones. First of all, we need to talk about what autonomous systems in drones, or the concept of autonomy itself, is. Autonomous means operating without a driver. That is, in situations where there is little to no human input, the device's electronic or mechanical parts work on their own, is the concept that has been built upon. When we say autonomous system, many different systems may come to mind. An unmanned ground vehicle or an electric vehicle can operate autonomously. These are generally done through sensors and cameras that can replace human input, and they are systems that can substitute for human input through a sensor or control board, processing environmental factors with their mechanical and electronic components. In drones, there are three types based on their mode of use. The very first of these systems is what we call manual systems. The second one is what we refer to as semi-autonomous systems, and the third and final one is what we refer to as fully autonomous systems. Now here we can also say fully autonomous. We'll explain what it means like this. What do we need to use a manual drone? We need a remote control. The remote control acts as a transmitter for us, and through a receiver on the drone, it allows the control station part, meaning the side of the person controlling it, allows the drone to move based on the incoming inputs. So we need a remote control. But it should not be forgotten that the remote control is actually the key to a drone. Here, when we look at semi-autonomous systems and fully autonomous systems, the use of a remote control is definitely required. Why do we need to use this? Because, fundamentally, you can also fly an autonomous system manually. You can also fly a semi-autonomous system manually. As a result, regardless of how drones are used, remote controls that can serve as an input key and are encrypted will be used, which can only control the connected drone system. So what does semi-autonomous system mean? Let's say you want to create a drone that goes from point A to point B. You can do this manually by moving your joysticks on the remote control and giving a command in real time, or you can input the joystick values on your remote control. For example, go from point A at 0 meters elevation, 100 meters north, 200 meters northwest, and then 20 meters south. Point B is also there. And if you give the command to stay at 7 meters elevation at point B, if you enter through the ground control station, you will have flown your drone in a semi-autonomous way. So what do we need for our semi-autonomous flying? First, we need a ground control station. We should also mention that mission planners are used as ground control stations in almost 90% of all open source software. What about the concept of fully autonomous? It's also worth mentioning this before moving on to the concept of fully autonomous. Along with semi-autonomous at the same time, we have to use the ground control station within fully autonomous as well. Now, at the ground control station, you can assign points to the locations the autonomous on-system will go to, and at the same time, you can also receive communication and telemetry data coming from the drone. What does that mean? For example, you can receive data on wind speed, flight altitude, or the current status of the mission through the ground control station, but the semi-autonomous system, you can directly assign the points and altitudes it will go to through the ground control station. In short, if we visualize it in our minds, a ground control station can control the drone without any intervention from the remote. Semi-autonomous systems require pre-uploaded data for control. Fully autonomous systems scan, detect issues, and alert authorities and users. In fully autonomous mode, we actually have a situation like this. Let's say after going from point A to point B, it scans the surroundings 360 degrees, and if it detects any abnormal situation, after identifying this abnormality, it needs to sequentially, let's say, notify the police, inform the user, issue a warning, and trigger an alarm. During this process of executing certain procedures related to our mission, we need fully autonomous capabilities. Why? Because after going from point A to point B, it needs to make a decision. It needs to identify something. Let's say it scanned 360 degrees. After that, it needs to analyze whether it has actually detected an abnormal situation. Here, if we assume that it detects an abnormal situation, It needs to do this through its own intelligence. Therefore, we would say that in order to operate a situation in a fully autonomous manner, you need an artificial intelligence system. Now, we can actually say that it is more advanced than manual drones. We can say that semi-autonomous systems are more advanced than manual systems. But at the same time, manual drones are actually less costly than semi-autonomous systems. And semi-autonomous drones are actually less costly than fully autonomous systems, because the costs of an artificial intelligence board are actually very high. Therefore, when you look at these drones, you can choose the autonomous operating systems based on the project you select. Especially, say I'm giving an example. You want to detect any kind of fire in a forest area, and you want to determine whether this fire is a stubble fire, a real forest fire, or a controlled burn. When you determine this, you definitely need to use a fully autonomous system. But no, you only want to transfer images, but using the drone from point A to point B and from point B to point C completely automatically. If you want it to go, you can use a semi-autonomous system, but if you need a device that will only be operated by a person and is meant for capturing aerial images, then you can use a manual drone system